Welcome to lecture number 9, Stanford CS193p, spring of 2025. I'm going to go to the demo for a brief time at the beginning here to talk about our pop quiz, the only pop quiz we have the quarter, and probably the only one we will have, but it was kind of a fun experiment. And then I also teased elapsed time. Remember that? I kind of teased, we could put elapsed time in there. So I'm actually going to show you how to do that. We'll just take a little time out and say, how would we do an elapsed timer like that in our UI? Then I'm going to hop back into the slides here and finish up talking about the Swift type system. You can see the things in gray there. We've already talked about those. So now I'm going to talk about protocol and class. Now you've read all about these protocols, especially in your reading assignment, so this is not going to be a lot of new stuff, but I'm just going to emphasize some things about protocols. And then I'm going to talk about 3 specific protocols, Equatable, Hashable, and Identifiable. And then if I have time at the end, which I might not, I'll go back to the demo and we'll actually do some stuff with Equatable, Hashable, and Identifiable so you can kind of see them in action. So let's hop over back to our demo. So our pop quiz, you'll all remember, was to fix this problem right here. So I'm going to make a guess and then I'm going to hit restart, and what's going to happen is that this guess row right here is going to fade out and then fade back in, kind of flash. So there it is, gone, and then it came back. And that's completely unnecessary there for it to disappear. And it is disappearing because we want it to disappear in the case where we got it right, which is yellow, yellow, brown, brown, right here, and we guessed, we got it right, and when we hit restart here, we do want it to fade in because it wasn't there. We took it away. Now we do want it to fade back in. So how would you approach an animation problem like this? I mean, animation problems, I'm sure you're all realizing, are kind of tricky. You're like, what's going on? Because it's all timing based, and like I say, all of the stuff in animation is happening after the fact, so it's hard to look in your code and see what state are things in because things have already changed, and so it can be a mess. So the number one thing I'm going to suggest when you're trying to track down an animation problem like this is to slow it down. Right? Slowing it down gives you time to breathe as you're watching things going on. So for us, that's going back over here to our little UI extensions and changing our animation from bouncy, let's say, to ease in, out, duration, let's say 2 seconds is probably enough, but I could go as slow as 5 seconds if I really wanted to see what was happening. And then if I go back to my code breaker view over here, and do the same thing. Here we go, click, click, click. It's going real slow. That's good. I guess that's going slow. And I'm going to restart, and I can see, oh yeah, it's fading out. Now the thing's moving out, and at the time it's moving out, it's coming back in. Now, what's the second thing to do when I'm trying to figure out what the heck is going on here? Well, I'm going to try and understand what views are involved. And I'm going to go look there to see if they have dot animations on them or dot transactions or something. And in this case, it's our guess. It's the guess that's fading out. So I'm going to go find my guess in my UI. It happens to be right here, code view, code game guess. That's my guess code view. So something's not right there. So these two guys right here immediately are top on the list of things that are a problem. And especially that opacity. If I look at animation nil, it's like my problem is not that my animation is nil. The problem is the opposite. My problem is my animation is happening and I don't want it to happen. It's fading that thing out and then fading it back in. I don't want it fading. So it's probably not going to be this animation nil. Sometimes I would have a problem where something's not animating, and that might be a prime suspect. But here I have the opposite problem. This is thus the likely problem. And actually, a few of you said, I'm going to fix this. I'll just comment that out. Get rid of that entirely. And actually, that does fix it. Watch this. Here we go. Go up here. Look here. Now I'm going to restart. Ready? Oh, it didn't fade out. Yes, I'm done with the pop quiz. Unfortunately, that's not quite right, because watch this. I'm going to guess the thing, which is black. What is it? Black, brown, orange, black. Orange, black, so I'm going to guess it right. Okay, got it, ready? And restart. And, see, we got the problem that we were trying to solve with that opacity, which is that the guess was fading in as the thing was sliding down, and we don't like that. We do not like things moving, especially as buttons slide in. Of all things, buttons sliding in really breaks the illusion. We don't like that. So this did not fix the problem. It was kind of a good idea. almost worked, but it didn't work. So a lot of you got this right away, and I'm not sure your thought process is, but you might have just thought, well, this darn thing is working great in the case where the game was successfully guessed, but it isn't working at all in the case where I didn't get the guess right. I went here and I clicked the wrong thing, and I'm in the middle of a game that's not finished yet. So this is where it's not working. So I'm just only going to do this animation in the case where I have finished the game, because that's when I need it. So you just went in here and you said restarting, and game.isOver. And so I'm only going to do this opacity trick if the game is over. In other words, if we've guessed the code. And this is a fantastic solution to this problem, because it really gets at what's happening here. When you want to do this opacity really only wants to happen when the game is over. That's why we put it in there, so we wouldn't have that overlap. So let's make sure that's working. Go. And we're going to restart, and hopefully guess will not fade out. It did not. Everything's fine. And now let's check the other case, which is brown, brown, green, brown. Okay. Yes. And we're going to restart, and let's hopefully it won't overlap again. There it is, not overlapping, and here it fades in perfectly. So that was a great solution to this problem. That was the one I kind of suggested with my hint, 15 characters or whatever. That's what that is really, really nice. I want to show you another way that we could have done this that I think might have been even slightly better, which is instead of putting this game over right here, this whole restarting thing where we're putting the things in and moving it down and all that, that only is for game over. We don't need to do any of that, moving the thing down and sliding it over and fading things, any of that in the case where we restart a game that wasn't properly guessed. So I'm going to put this game over, instead of putting it up here, I'm going to put it down here when I restart. So I'm not even going to set restarting to true unless my game is over, because that's the only time you need to do this whole two-stage animation thing. So I'm just going to put it here, and that keeps me from having to do it up there. Let's make sure this works. Let's just check the game over case first. That's orange, yellow, black, yellow, orange, black, yellow, and yes. Let's make sure we don't have the overlap or anything here. Yeah, working. Yes, nice. Fades in. Beautiful. And how about in the other case? Here, guess. All right, and restart. Nice, doesn't blink. Excellent. So that's nice. And if you put this here, you'll actually realize we don't even need to do the slide down anymore. That slide down, we did it to get it out of the way of the guest coming in. But look what we've done. We've postponed the guest coming in until after that thing's gone anyway. So we don't even need to do the slide down, which means this little restart here can be moved up into here. All right? We can just do the restart right away, move those things out of the way. And we do not want this little restarting right here, which is the thing that puts the guest back so that things move down, right? So I'm just going to take this or restarting off of here so that the guest code is just not even there until we're finished restarting. And let's see if this works. We'll go here. Let's try this one first. This is the is not a match case. Restart. Oh, yes, looks good. And now the all-important orange, brown, black, brown, black. We go guess. Ready? Hopefully no overlaps here. Restart. Woo! Perfect. So I think this is probably the ultimate solution right here. We don't even need that push down, although some will argue the push down looks kind of cool. So maybe we should leave it in there just for fun. But we certainly don't need it for the actual operation of the game. Questions about that? One other thing I wanted to say that this just reminds me of, I noticed that quite a number of you are using the view modifier frame. Okay, how many people have used the view modifier frame in your assignment 3? .frame. Okay, well, see half of you. Frame can be okay. Frame has a lot of different arguments to it. Like, for example, it has max height and max width. Those are not bad arguments to frame because that's limiting the amount of size that something can be. But frame also has some arguments you want to stay away from, like width and height. Okay, frame width and frame height, that sets the width and height of a view to a fixed thing. And the reason we want to stay away from that is that in assignment 4, I'm going to make you make your app work on the iPad. And if you've set, for example, your keyboard buttons to be really small, when it runs on the iPad, it's going to look ridiculous because it's going to be much larger and you're going to have this tiny little keyboard, okay? So please do not use dot frame with a width and height, okay? You really don't want to be doing that. You want to learn how to design your user interfaces so they stretch and shrink to fit the space available, whether that's iPhone in landscape mode or in portrait mode, or whether it's an iPad or whatever, right? Or even Apple Watch or something. Yeah.
What would you do to make sure they're all the same size then?
Yeah, so the question is, so what would I do then if I need them all to be the same size? And I actually give a hint in the assignment about that, which is try and use aspect ratios as best you can. You want the aspect of the ratios of the keys to all be the same, and then maybe you can use the aspect ratio of the whole keyboard to try and enforce what you want there as well. Okay, and then there's other solutions too. You could put hidden views in there if you want, right? Put a view in there that's just not showing, but is using up space. That's another possible solution. Yeah.
I saw a suggestion on to use geometry readers, so if you did that.
Yeah, so the question is, I saw a suggestion someone made to use Geometry Reader. Okay, so Geometry Reader, awesome little view, don't get me wrong, but I haven't shown you how to use like that, so I'm not expecting that you use Geometry Reader. It certainly could be used in this case. Geometry Reader, by the way, is just a fully flexible view that when it has the things in its container, its little view builder, it passes it a little argument, which is how big I am. Okay, so it's just, that's all it is, a flexible container that tells the things inside of it, this is how big I am. So you can imagine how that could be used possibly to do this. But I haven't talked to you about that. I didn't expect you to use it. I'd kind of like you to not use it, although I won't count it against you if you do. And the reason I don't want you to use it is I want you to get experience with using aspect ratio and other things to make things, stretch and fit the space. That's good experience to have in general. All right, good questions though. All right, so elapsed time, shall we do that one really quickly? If you remember, I teased it by going here to my code and I added an ancillary view, which was just a text that said 0:10 seconds or whatever. And look at that, we got a countdown timer, woohoo, but of course it's not counting down. And I'm sure you're like, well, how would you do that? And especially, how would you make that thing count down? How would we do that? What we're going to do instead of a text right here is we're going to make our own helicopter view. I'm going to call it elapsed time. And it needs to know the start time, when our game started. So I'm going to have some game.startTime or something like that. We'll have to add that to our model. And then it also needs to know the end time, because when the game's over, it's got to stop counting. So let's go back to our model, our game, and add these two things. And we're going to have our model totally own the responsibility for figuring out elapsed time. The UI will be displaying it, of course, but the model is going to keep track of it for us. All right, so let's go back to our model. Here we go, model, code breaker. And I'm just going to add a couple of vars for that. Var start time, which is, of course, going to be a date. Date is the struct in Swift that represents any moment in time, date and time. And it actually has a nice value, a static called now, date.now. That means right now. So I'm going to set my start time of my game to be when you created the game. You call its initializer, it's going to start the timer. Now that's maybe not quite right, because maybe we don't put it on screen right away, and we really only want to start the timer when it comes on screen, and we're going to do that next week. But today I'm just going to start the timer right away as soon as you create the game. And then I also need an end timer. Now the end time here, that has to be an optional date, right? Because when I start my game, it hasn't ended yet, so I don't know the end time. And anytime we have something we don't know, we make it an optional. Is everyone cool with this being an optional, right? So we just need to set the start time and end time at the right times. We're already setting the start time at the right time. What about the end time? Well, we want to set that when the game is over. So when is the game over? That's when we attempt to guess, and it is over. Everyone agree that this is the right place to put that? We attempted to guess, and the game is over. So it must have had a match. End time equals .now. And again, I use type inference there. That's date.now, but I can just say .now. Yeah.
If we get the end time before setting that sequence would be false.
Yeah, that's a great question. So the question is doing this the same as doing this? And the answer is yes and no. For my model, no, it's not the same thing because I'm setting those in that order, and so maybe if setting my master code depends on the end time, somehow that would matter. For the UI, it does not matter. Because the way the UI works is you call a function in your model, it changes things, and then the UI reacts. But those changes all happened atomically. You know what I mean? Like they happened as one. It's not watching you as you change every var inside the function. It's just you called a mutating function, attempt guess, and then it's got to update the UI to react to it. And it doesn't matter here either because our master code being hidden or not has no effect for end time either. So we don't care here either. All right, I think that's it. What about restart? Right, when we restart our game, we got to reset our start time. So I'm going to say start time equals .now when we restart, and the end time goes back to being nil, not set, because I just restarted the game. So I want my thing to reset and start ticking again. Everybody cool with that? All right, so that's it for the model. That's all the model needs. Now let's go back to our UI and write this little elapsed time view. I'm going to go up here and say File, New, from a template. It is, of course, a SwiftUI view. It's a helicopter view. It's called elapsed time. I'm going to make sure it's in my UI group because it's a UI thing. It's a view, so I'll recreate it. Here it is. And, you know, I could have this thing, let's say, start with 0, 10, so you can see it on screen. But it does have these arguments, the start time, which is a date, and no default there. And it also has the end time, which is a date question mark, right? These are just the two arguments over here that I'm passing to elapsed time. And it's rebuilding. I think it should probably work, actually. Maybe like something not build here. Oh, my preview. Let's get rid of that. So we won't preview the elapsed time here. There it is. See, got my 10 seconds. This little guy right here, if I change this to 11, so there's 11. Now, we want this text to not be fixed like this. We want this text to somehow calculate the difference between the start time and the end time, or the start time and now, and show that. So to do that, I'm going to talk about something in text we haven't mentioned, but it's one of these ones you want to go to the documentation and look all these things, which is that text can actually show non-strings. Like I could show 0.4. But to do it, I have to give another argument, which is a formatter. And there are a ton of formatters, like formatted as a number. Look at that. See? They put it on the screen, 0.4. You could also format it as a percent. Look at that, 40%. And these formatters let you take all kinds of different things here. Numbers, floating point numbers, ints, dates, and format them. Let's go look at what formats are available. So I'm just going to option click on text and go into the documentation. Scroll all the way down to open in developer documentation. Here it is. And then I'm going to actually search for format. Get down and find this format thing. Here it is, init with format. See, that's init with something here and format. I'm clicking on that. Here it is. And this format that we can do is this format style right here. F is a format style. This is generic type, right? F, where, this is where F is a format style. Everyone hopefully starting to get comfortable with that. And then here's the format. If we look down here, we'll see all the things we can do. Look, number with all different kinds, integers and floating point numbers, etc. We've got percent. I showed you that one. We've got date and time. So this is the date and time formatter is great because you can say, oh, I just want to show the day of the week, or the hour, or the full date in full words, or date in small numbers, or whatever. You can completely control that with this formatter. And it's got currencies. You want to show something in your current currency, it'll put the right currency symbol on there. It's got measurements. That's like lengths and weights. It knows how to do those. It even knows how to take this thing called a person name component struct and show somebody's name properly in the UI. So this is quite amazing, all the things this format can do. So you really want to check this one out. It's a great way to show data on screen. Now the one I want is called offset. Offset is a formatter that shows the difference between two dates, the offset in time. And showing an offset between two dates, maybe it's years, maybe it's seconds, maybe it's minutes. And this lets you kind of control which fields, like minutes, seconds, hours, whatever, you're going to show. And it shows as an offset. So this is the one I want. And if you look at offset here, it says offset to date. So you're formatting a date, and it's being formatted as an offset to some other date. So in our case, the thing we're going to display is either the end time or now, and offset it to the start time. And then it's also got this allowed fields thing, which we're going to use. We're going to only show minutes and seconds, because this game is not going to last hours. It's going to last maybe only seconds, but certainly minutes and seconds should be fine. So this is the one we're going to use, this formatter right here. Let's go back and make this text right here be our end time. But the problem here is that our end time is an optional. So I'm going to have to say if let end time, I guess, equals end time, then do this. I'm basically trying to use an if let to look at the value of end time there. And this is very common to essentially want to unwrap an optional like end time and call it the same thing. So if I do this end time equals end time, this is a different variable than this. This is this end time, the green end time, that's self.end time basically. And this is a local variable that I just let equal to something, the black end time. And this one only is valid inside here, right? Everyone knows about if let, right? We talked about if let. But when we do this if let end time equals end time, we are allowed to get rid of that. So if you just say if let end time, you're basically saying if let a local variable called end time equal this other end time thing. We do this all the time where we're doing if let end time. And by the way, there's an else case here where we want to show the text of basically date.now with the right formatter, that offset formatter. So this is all our elapsed time is going to do. We just have to put the right formatter here and we'll have it going. So let's do it. It's an offset formatter. I'm just letting type inference pick whatever the type of it here. And it's to our start time. That's not an optional, so we're fine. And it has this allowed fields argument, which I'm going to say I want to allow .minute and .second. So this formatter will take a date and show it as an offset to this time. That's exactly what we want here, right? Exactly what we want. And I'm going to do that same formatter down here. They're both going to use exactly the same formatter. Now look at our UI. It's saying 0. But it's not ticking. It's just saying 0, even though this game has started. And look, even if I'm playing the game and it's 0 and 0 and 0. Although, watch this. If I finish the game, orange, brown, 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 orange, brown, 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 okay, guess. Woo, look, it updated. 23 seconds I took to play that game. So it is working. This line of code definitely worked right here. It got the end time that I said, and it showed it as an offset from the start time. But why was this always showing 0? Well, that's because this is an offset from date.now. And date.now means right now. And when is that evaluated? When this var body was requested. Whenever SwiftUI said, give me the var body for elapsed time, it evaluated date.now. Well, of course, it did that the instant the game started, and so it was at 0, 0. It hadn't had a chance to even tick a millisecond, probably, and it asked for this var body. And it never asked for this var body again until end time changed. When end time changed, SwiftUI said, oh, something inside var body has changed. I need to ask for it again. Does that make sense? Remember that SwiftUI is super, super efficient about not calling var body unless something actually changed. And date.now is not some kind of running counter. It is the date right now. That is all it is. So this is your question that you asked earlier. It's like, well, how do we get this thing to count? And the answer is we can't use date.now here. But luckily, there is a really cool thing called a time data source. And it's a generic type. And it has a thing called current date. And current date is this magic thing that is a data source for the current time. And it's just always supplying it. And text knows how to deal with this so that it will tick. And look what's happening in our UI. It is ticking. You see? So this is actually updating inside that text. So our var body is not being constantly reevaluated. It's just that text on the inside knows to redraw its var body because this data source is ticking. There's a little bit of not so nice here. Look how tiny our little elapsed timer is there. There's plenty more room for it to be larger. So what we really kind of want is for it to fill up the space. Well, guess what? We invented our own view modifier to do exactly that. Remember, for the guest button right here, we have this flexible system font, which we created. Well, there's no reason I can't use it here. .flexible system font. I don't know why AI wants to put that on there. It has nothing to do with it. And look at that. It's bigger. Now, this is still not quite right because this is not a monospace font. So if you watch, when it goes to like 11, watch what happens. See, it got bigger and smaller. So it's kind of getting bigger and smaller because the numbers, ones are smaller than twos. And you see what I'm saying is happening there? So it's zooming in and out a little. So I don't want that. So I'm actually going to make this a monospace font. And as we have learned for most things, there's a view modifier for that called monospaced. And that makes anything monospaced. And this kind of fixes it, but now it really looks bad because it's wrapping. So it's doing what we said, which is make this fit perfectly in this space, but it's doing by wrapping. And we don't want wrapping here. That looks absolutely terrible. But there's a view modifier for that. It's called line limit. And line limit says any text inside this thing has to be on one line. And look at that, it put it on one line. Any questions about that? So I'm actually going to comment this out because I don't want you to be distracted by that thing ticking over there as we're changing other things. So now we're going to talk some more about the Swift type system. All right, we covered kind of the main things of the Swift type system, but now let's talk about protocol and class in a little more detail. So first of all, protocol. So a protocol, you all have read your homework, right? You read the reading assignment. You know what a protocol is. You've seen all this. So I just want to emphasize it. A protocol looks like a struct, but it has no code in there. And when it has the curly braces like that, that's just saying whether this is a read-only var or a read and write var, right? It's either get or get set. That's the only thing that can be in those curly braces there. And if it were a func, if there were a func in this protocol, which there's not, there would be nothing there. Okay, no curly braces whatsoever. So we're used to this. We understand what's going on here. And this makes it so that if we do struct content view behaves like a view, we have to implement this var. That's what it means to behave like a view, is to implement this var right here. Now I'm going to show you some other protocols in these slides, and I just want you to realize that protocols can have many funcs in there, not just one. I just happen to be showing you 4 protocols that each only have one thing in them, okay? But that's just because I'm showing you simple protocols, right? But they're definitely protocols that have, 6 or 7 functions in there that you have to implement. But my examples only have one. All right, why do we have protocols? What are protocols for? What's going on? And I told you at the beginning of the quarter that Swift is a protocol-oriented language. Okay, so it's like protocols must be important if it's a protocol-oriented language. Why do we have them? Well, the number one reason we have them is because they serve as a contract between different parts of your code. So that code over here can know what this code over there can do because it knows the protocol it implements, and so it knows the funcs and vars that I can call in it, right? So it's a contract. It's a contract maker. That's conceptually what protocols are about. But practically, protocols are about code sharing. A big part of protocols is sharing code between things, like sharing all those view modifiers between all of our views. It's a big part of it. It also, we don't use it this way very much, although we have used it once this way, is that protocols are part of the type system. They can be used as types. Anywhere a type can be used, right? Vars, arguments, types of arguments, return values, etc. So we're going to talk about that. And then the last use of protocols is what I call constraints and gains. Okay, I call it that because it's got a little rhyme to it. And this is really where protocols, when we say it's a protocol-oriented language, it all comes together. So let's talk about these 4 things. The first one, actually, we don't have to say much about. I think everyone understands what I mean by this. Where clearly, if we're defining protocols that have funcs and vars in it, we're clearly making it clear to other parts of my code what I can do. Okay, that's just kind of obvious, but I bring this up as the first slide just so you put it in context that that's what we're doing with protocols, is making it so that all parts of our code know what other parts of our code can do. Okay, but let's talk about the specific practical nature here. like the code sharing. Now, I say this, protocols are about code sharing, and people are saying, what are you talking about? You just told me the protocols have no code in them. How could they possibly be code sharing things? Well, the answer is extension, all right? The combination of extension, which you know what that is, and protocols is a powerful combination, and it allows you to extend protocols to add code. This is how all of the view modifiers of the view protocol got added to it. Someone at Apple sat down and they typed extension view, and they typed in func font, and all those things all got added by extension. So this is how we code share with protocols. If we say we behave like a view, we get all the things anyone's ever added as an extension to the view protocol. So we are sharing a ton of code between all our views. Everyone see how that works? Okay, so extension is the magic word there. Now, what about using protocol as a type? I'm going to go through these slides quickly, and I want to say right up front, this is not very important. This is not a super important use of protocols. Okay, this is not anywhere near as important as code sharing or the constraints and gains I'm going to talk about. When we use a protocol as a type, we need to think about what we actually mean by having the type be a protocol, and we express that in our code with two keywords, some and any. And depending on which of these keywords we use, kind of says what we mean by having a protocol be a type. So let's talk about these two keywords. Let's talk about some first. The some keyword is used to hide a concrete type, either from the caller of a function or from the callee. Okay, one of the two is having the actual type that's implementing the protocol be hidden. And hiding a type has a lot of advantages because it allows one side of either the callee or the caller to have flexibility to do what they want in terms of a concrete implementation of that protocol without forcing the other side, the caller or the callee, to have to adapt to that and deal with it and be constrained by that, you see? So let's talk about these two cases when this happens. When some is in a return type, like var body, some view, then it's hiding the concrete type from the caller. The person calling var body does not know the type of thing that's being returned. All it knows is that it's some view. Okay? The caller, the callee, the person implementing var body, that definitely knows. It's calculating what that thing is inside of its computed property. What about the other way? Well, if you use some as a parameter type, like you have a func and one of its arguments is some view, now you're hiding it from the callee. Okay? The func that's receiving this some view doesn't know what kind of view it is, it just knows that it's some view. So inside that func, I can only use view protocol things, which means I can only use var body and all the things added with extensions. That's all I can use, because I don't know what it is, you see? So some is used kind of to hide things from one side or the other. So the var body one I talked about, I think that's obvious to you. That's what's happening, that hiding. And then on the other side, we actually had an example of it, which was the animation view modifier. Remember, its value argument was some equatable. That means it can be anything, but it's an equatable. Inside the implementation of this view modifier that Apple wrote, it can only call equals equals on that thing. That's all it can do, because that's all it knows that it can do. It knows nothing about what it is. But on the outside, of course, we know exactly what we're passing to animation, right? As the caller, our attempts.count or whatever we're doing, we know. Pretty cool there? So some, interesting thing about some is it's known at compile time, right? Some really means some specific type of that protocol, some type of view or some type of equatable. It's something, and it's known at compile time to the compiler, because the compiler either sees the caller side or the callee side, so it can tell from one of those two what the type is. But there's another thing here called any. So if you put any in front of something like any view, okay, any means any concrete type, not some particular one, but any concrete type can go here. So this is, for example, if you wanted to have an array of views where the views were all different, that would have to be any view, because that array doesn't have some kind of view like a peg view. It has any kind of view, a peg view, a marker view, match markers view, anything. It could be their text, right? So that's why it's any view right there. Now, the interesting thing about this one is the compiler can't know this type until runtime. Because until you ask for which one of the ones you want out of the array, it can't know its type. So this is a runtime binding kind of mechanism where the compiler has to build some infrastructure so that at runtime we can figure this thing out. And it does this with something called boxing, and I'm not going to talk about this, but you can think of it as it puts the view into a little box, and it puts that in the array. It puts the box in the array, basically, and then when you pull something out of it, it unboxes it, figures out its type, and then figures out what function to call based on what type it is. It's not cheap to do, okay? It's not super efficient. We call these things existential types. It's kind of like there exists in the world something that is any view, okay? It exists. It's existential. And Swift resolves this at runtime at a cost. It's not free to figure out, this at runtime. But performance is usually not a huge issue with the UI, but it's slightly something to think about. But the main thing about any is that it's basically relaxing Swift's strong typing. I told you that Swift is the strongest typed language in the universe. Everything has to have a known type. Think about that horrendous type we had with the in our very first lecture, that tuple view, right? And it was generic, and it had the text. I think it was very strongly typed, exactly what was in there. And this relaxes that quite a bit, because now you're saying, well, it's any kind of view actually here, and that is really not something we want to be doing. I mean, we like that Swift is strongly typed. So I'm going to make this statement here that some is greatly preferred over any. And I'm even going to go so far as to say, if you think you need to use any in this class, you need to contact me first, okay? Because I doubt it. And there's a kind of impulse to just go to using any because a lot of you come from languages where everything's in any, okay? It's loosely typed, and so you're just used to putting arrays of anything in there you want. But don't fall into that trap here, okay? And look at our views of any view up there. We would never do that, ever, in SwiftUI. Why? Because we have View Builder. View Builder built a very strongly typed list of views. Why would we ever want to use this untyped one, right? So we usually have better things to do than any. And so in this class, if you feel like in your final project you need to use any, or certainly in the homework, you need to contact me first and get my approval, okay? Because I want to hear why you think you need to do it. All right? So that's it, using protocols as types. Again, not that common. We've seen the most common use of it, which is var body sum view, the return type of var body. That's the most common use of protocol as type that we've ever seen. All right, constraints and gains. We already know that we use protocols to gain a ton of functionality, right? In our views, we implement var body and we gain a massive amount of functionality instantly. But we also have seen that we use protocols to constrain other types, especially generic types, to be sure they do what we want. For example, our ancillary view, right? When we had our ancillary view and code view, we passed that as a view and we constrained it by saying where this ancillary view behaves like a view. So we constrained it. It was a don't care, but then it became a care a little bit. So I call this dichotomy here of gaining a lot of functionality, but constraining, constraints and gains. And that's one of the main things that protocols are used for. Now, another example, in addition to ancillary view, is dictionary. So dictionary, you might have used it in your assignments, maybe not. It's essentially a hash table. And dictionary has two don't cares. The types of the keys in the hash table and the types of the value. It doesn't care what type that is, either of those types. However, it does care that the keys are hashable. Because it's a hash table, it has to be able to hash those keys so it can get the values, right? So it just says where keys implement the hashable protocol, which we're going to talk about in a second. So that's similar to ancillary view. So combining then where and extension, which we've talked about together, results in very powerful and flexible code sharing. And I'm going to show you a great example of that with array and equatable in a few slides here. All right? So all these things kind of come together. The constraints and gains and the where clause and the extension, all that stuff, it all comes together in a very kind of sensible, powerful way. So let's talk about 3 protocols that really are infused all through SwiftUI. They're not used that much, but when you come across them or when you need them, you need to know what they are. So let's talk about them. That's Equatable, Hashable, and Identifiable, right? Equatable makes the equals sign work. Hashable is when you want to put something in a dictionary or use something in the UI that needs hashable. And then Identifiable is really how SwiftUI is going to match up your model, which has got structs in it, which don't have a really good sense of their identity, with the views that are in your UI. You need to match those up. We need to make our structs a little more identifiable. So talk about equatability first. One thing to know about Swift, I might have mentioned this, the equals sign is not built into the language. Okay? Equals is not part of the Swift language. Equals is just a func that some structs implement, and the structs that implement it conform to equatable. Okay? And that's all equals is, believe it or not. It's just some syntactic sugar there that when you use it, it calls the right function as long as the things that you're comparing are equatable. So you implement equatable, of course, by conforming to the Equatable Protocol, by saying :equatable. And if you put :equatable, well, first of all, you don't even need to put :equatable on a lot of things. Like if you have an enum that has no associated data, it's just automatically got equatable. It kind of comes with the territories. That's somewhat built into the language, I guess you would say. But if things don't have that, then it will actually synthesize equatable for you if you just put :equatable on it. So if you have a struct of your own or an enum of your own, you put :equatable on it, then many times Swift can make that equals function for you. They make it just automatically work. Now, when can you do that? Well, if you're a struct, it's if all your vars are equatable, then it will just equate all your vars, and that's the equatability. Or if you're an enum, as long as all your associated data, right, has it, then it'll do it. Now, we already saw all this. I did this with kind. Remember kind? I added associated data, and it broke equals on it. So I just said :equatable, and it just started working again. Well, that's because all of kind's associated data was equatable, so it was able to synthesize it for me. But what if it can't do that? What if not all your vars are equatable and you have to implement equatability? Well, then you have to implement the protocol, and this is what the Equatable Protocol looks like. It has a static func in it, okay, a function on the type. It's called equals. That is a valid name of a Swift function, equals. And it has 2 arguments, the left-hand side and the right-hand side. And the operator equals in the language knows to call this thing. Right? It's going to call this thing for whatever the 2 things are on the 2 sides. Now let's talk about purple self right here, capital S self. What the heck is that? We already know that lowercase self means myself inside an instance, right? Inside of a method, like in our inits, we would do self dot name of our var equals the var that's the parameter. So that's lowercase self. Uppercase self means the type that is implementing this protocol. Okay, so it's the type. Self is the instance. S, capital S self is the type. Got that? Right? Lowercase self is the instance of self. Capital S self is the type. So if I was implementing equals protocol in kind, I would be static func equals left-hand side kind, right-hand side kind. I could leave it as left-hand side capital S self because that's what it means inside kind. Okay, inside kind, capital S self is kind. So now I told you I was going to bring it all together, all this stuff, where and protocols and extensions, with array and equatable. So I told you earlier that if you have an array of things that are equatable, then the array is equatable. So I can say, does this array equal this other array, as long as the things in the array are the same type and it is an equatable type. So how is that implemented? What does the code inside the libraries look like for this? Well, it looks like this. Someone has created an extension to an array that implements the Equatable Protocol. So first notice that we can add conformance to a protocol via an extension. Right? This is an extension to array, and it's adding equatable conformance. It's making array equatable. However, look at the purple. Where element, which is arrays don't care, conforms to equatable. So this extension only applies to arrays where the don't care in the array is equatable. Okay? Otherwise, this just has no effect on an array where that's not true. Pretty cool with this? So now you see how we've combined all the things here? Extension, protocol, where, all combined to make this great little thing. And then, to make equatable work, I just have to implement equals equals. The left-hand side and the right-hand side have to be an array of my don't care, of course. And inside, I'm just going to check for, now by the way, I wrote this, so I don't know if this is written this way at Apple, probably not, but I'm checking to see if the arrays are the same length, right? Left-hand side count equals right-hand side. And then I'm using this cool function called allSatisfy, which you give it a closure, and it calls that closure on every single thing. And as long as they're all true, then they all satisfy it. So I'm having my little closure ask if the left-hand side of that index, right? I'm doing left-hand side .indices.allSatisfy. So I'm saying if the left-hand side of that index equals the right-hand side of that index, then they're equal. And if all of them satisfy that, then my arrays are equal. Does everyone agree that this code would calculate that? But it's interesting to look here that the double equals that I'm using in there simply would not work if I didn't put the purple where. Right? I mean, the compiler would not even let me call that equals equals there because the left-hand side and the right-hand side's elements wouldn't implement equatable. So they wouldn't have that function, equals equals. Right? So do you see how it all comes together here? Where, extension, protocols, it all comes together in this very natural way where you get to write really simple, straightforward code like this. And we've just made every single array in the world that is an array of equatables be equatable with just these 3 lines of code. Right? Okay. Let's talk about equatable and using it in the UI, using it in SwiftUI. One of the nice benefits of it is on change of. Right, this thing we saw on change of. The argument to on change of is some equatable. So if you want to be able to do on change of one of your own personal types, like struct code or something like that, then you would implement equatable in your custom type. And then you could say on change of this code, right? It's pretty cool. One thing you want to think about, oh yeah, here's an example of doing that, right? If I on change of here, game.attempts.count. Okay, that's an int. Ints are equatable. So I could then inside there go do something when I made an attempt or reset my game. Those would both change my attempts count, right? It's really kind of valuable. But I do want to give you a warning here about equatable and the UI, is that the UI will use your equatable to see if something has changed, because SwiftUI wants to be very conservative about calling var body. It doesn't want to call var body unless something has actually changed. So be careful if you implement equatable that is really what you mean, that these two things are really equatable. And I use this great example here. What if I went into my code, struct code in CodeBreaker, and I implemented equatable and made it so that any two codes with the same pegs are equatable? Now you might think, yeah, that sounds good. Actually, that's going to be great because then I can write code that says, is my master code equal to this attempt? And it's just going to work because it's going to only check the pegs. However, that's going to break your UI because in your UI, when you say, oh, let's change this master code from hidden to not hidden, that's not going to update the UI because the master code has not changed. Right? The pegs did not change, so it's equals equals to the previous version. You see the problem there? So if you're going to implement equatable, you want to really think about what you mean by equatable. And I tend to be on the conservative side and say, if I'm going to say equals equals, it means it's completely equals equals, including the kind and the pegs in the code. Yeah.
So in general, do you want all of our structs to conform to equatable for UI update?
Great question. So the question is, so would it be a good idea if all of our structs in our model implemented equatable, to help the UI out or whatever, to kind of help it be as efficient as possible? And the answer is no. Okay, we definitely don't want to do that. Remember that structs, the concept of mutability is very much baked in to the value type. That's why we have to say mutating func when we have a func that's mutating. So Swift knows when structs change. And so it's going to use that. If we don't have equatable, it's going to use that. And that's almost always right. Okay, because if we call a mutating func, it's likely that it changes something. It doesn't have to, but it's likely it did. So I would say the answer is no. I would not do that.
There's other ways to switch though. It doesn't allow equatable.
Yes. So,
Use it if it doesn't.
yeah, the question is, does it use other ways besides equatable? And the answer is yes. It uses mutating. When it mutates, it knows that that happens. That's a good question. All right. Let's talk about another protocol here. Hashable. Okay, hashable is about hashability. Everyone knows what a hash table is, right? You can look something up in a hash table. One thing about something that's hashable, and this is true in any system that does hashing, is that two things that are equals should never hash to a different value. That would be very bad in any hashing system. Now, the opposite is not true. You can have two things that are not equal that hash to the same value. That's okay, because you're then going to equals them to make sure they're actually the same. But you never want to have this direction. Two things that are equals should never hash to a different value. So that's just basic understanding of how to implement hashability. So let's talk about the hashable protocol and what this thing looks like. And you can see that hashable is kind of interesting. It has that purple thing, colon equatable, after it. And that means that this protocol has to behave like an equatable, meaning that you can't implement hashable unless you're also equatable. This is protocol inheritance, basically, when I think about it. And it makes sense, because why would I ever hash something if I'm not going to then do equals to make sure it's the thing I was actually looking for in the hash table? Okay, it's just always going to do that, so it makes no sense to have something that's hashable and not equatable, so we make the protocol require that. So if I were going to implement hashable in my struct, I'd have to implement hashable and equatable. I have to implement them both. And again, I could use Swift to synthesize it for me if I had all the right conditions, but I would have to. Now let's talk about how this thing works. This is just a single function in the hashable protocol, which is hash into, and it's essentially saying implement this function hash into, which turns yourself into a hashable thing by using this hasher, the blue thing, to combine elements of your struct or whatever that need to be hashed. And it's usually all the things that are involved in equatable, because of this thing where two things that are equals should never hash to a different value. So you want to at least involve all the things that are involved in being equatable into your hashability. And you do this combination by calling this thing combine on the blue thing. Now, the things you're combining to make your hash code are other hash codes, other hashable things. So it's kind of recursive here. You're having to kind of keep hashing all the way down. Now, you're going to look at this and you're going to see that in-out parameter. How many people from their reading know what in-out is? See, almost nobody. Okay. So in-out, don't worry about it. You'll maybe run across it in the reading. We rarely, if ever, use it. It's kind of a weird way to have a parameter. You pass it into a function. The function can change it, and it gets passed back out when the function ends. So it's really kind of weird. We don't really use that much. Yeah. Sorry. If the question is it passing something by reference? Almost. It's almost passing it by reference, but in fact it is in-out. In other words, it passes in read-only, you change it, and then when the thing is done, it passes back out and gets assigned. So it's almost by reference, but it's actually truly in-out. Again, the reason I say don't pay attention to it is I don't ever want you to use it. We don't even think that way with value programming generally. There's a few in-outs in Swift. This is kind of an unfortunate one, I think, but don't worry about it. But the bottom line is it does it this way because it wants to pass you the hasher. And I think it's maybe for efficiency. It wants you to pass you the hasher and have you mutate the hasher with your combined thing. I'm not sure exactly why they chose this approach, but it wouldn't be my favor. There must be a reason. There must be a performance reason or something. So to implement your hash into function inside the hashable program, you're just going to say hasher.combine this thing, hasher.combine that thing. You're going to combine all the things of yourself that you want to be hashed to be your hash code. It's as simple as that. And just like with Equatable, if you mark your struct as hashable, it can probably synthesize it as long as all your vars are hashable or all your association data is hashable. It can just make it for you. You don't even have to do this thing as long as that's true. Right? So that's auto-synthesis of these protocols. All right, so that's it for hashable. not super important, but it shows up in a couple of places, which you'll see here later in this slides. And if we get to the demo, then you'll see it in the demo too. So let's talk about the third protocol here, which is talking about identity in SwiftUI. So why do we need identity? What is identity about? And I've actually talked about this before. Your UI is driven by your model. It's a visual manifestation of your model. And SwiftUI has to be able to keep the UI in sync with your model. And your model is changing. You're calling, mutating funcs and doing all kinds of things. And so as that stuff is changing, SwiftUI needs to keep track of it all, especially when it comes to animation, right? You're changing things in a collection and it's moving around, and the views need to move around as well, right? Imagine you had a VStack for each things and you're moving things around in the collection that the for each is doing. The views need to move around to match, and they need to stay animated as well. So there has to be some concept of identity, of identifying the things in your model so the UI can track them essentially. Now, an obvious example of this is for each. For each, you give it a collection, right? And it constructs a view for each thing in the collection. Now, as your collection changes, the for each keeps the views that it creates matched up and in sync with the things in your selection. And that means that for each has to have, for every element in the collection, a unique, meaning it's different for everything in the collection, stable, meaning it continues to identify that thing even as you add and remove items from the collection, identifier for every single thing in the collection. Okay? Unique and stable. Those are two very important things. And there's a couple ways you can do this. One is by specifying some var in yourself that is a unique stable identifier of yourself. Okay? That's one common way to do it. Another way to do it is to have the items in the collection implement the identifiable protocol. That's what it's essentially for. And that means that I have a collection of identifiable things, and when the for each wants to match them up, it's going to use the identifiable protocol, which we'll see in a moment here, to identify that thing and match it up with the view it makes. All right? Now, in either case, whether you're specifying a var, which is what we've done so far, by the way, or whether you're doing the identifiable protocol, three things you got to have that identifier have. One, got to be unique. Two, got to be stable. We talked about those. And the third thing, it's got to be hashable. That's because for each is going to build a hash table of the identifiers of the things selection and the views it creates, right? So it has to be hashable. So we're always going to try and make sure that all of the things we use as an identifier for each satisfy all three of these. And we're going to see that that could be a problem with the way we've been doing it so far with indices, all right? So I'm going to talk about the identifiable protocol in a minute, but first let's talk about just the first way up there, which is using a var on your thing in the collection, to uniquely and stably identify it. And you do that with the ID parameter, right? Everybody knows that. We've been doing ID \self, but the ID parameter lets you specify any var, actually, and even though we've been doing \self. Of course, if you use \self as your unique stable identifier, that means that you yourself are hashable and unique inside that collection, right? And you stay the same. You're stable as the thing changes. And that has not been true so far for us, so we have not been able to use .self. Instead, we've used indices as a proxy for identity. Okay, do you understand what I mean by a proxy? It's like we don't have, for our attempts in Codebreaker, since in your assignment, you enforced them being unique, right? In assignment 2, I said you got to make your things be unique, but I don't do it. So I can't use the attempts themselves somehow as a unique identifier. It's not unique. So I've used the indices into the array because I know that's unique. It's not 0, 1, 1, 2, 3. It's 0, 1, 2, 3, 4. That is unique. All those things are unique. And that's what I've been doing. And so it's great. Indices are great for the unique. It's also great for hashable because ints are hashable. But it's not so good for stability, okay? And so when you think about stability in indices, it only works if you never reorder your collection, because as soon as you reorder it, you've changed which indices go with which things in the collection. So you've totally messed that up. It also means you can never remove or add something from the collection except at the end, okay? Because if you add something in the middle, it'll push down the other indices. Now, again, they won't match up. So this worked for us in our attempts because we only added attempts, right? We just added attempts at the end. It was fine. It never changed it. So we were able to use indices as a proxy. But I am kind of highlighting this with red text here because I don't want you to come away from what I've done in lecture so far and think, oh, well, I always use indices when I have an array of things. Okay? You can only use indices when you have an array of things with a for each in certain circumstances, basically these circumstances, where you don't reorder the items, you only add items or remove them from the end. That's the only way you can do it. You see why? So indices are great, but only limited. So what if the items you have in a collection themselves are not unique, stable, or hashable, like most things would not be? Then obviously you can't use \self to be the things themselves, like our attempts aren't this way because they're not unique. But you could still use some other var, okay? id : pegs, for example. You could use that in your assignment too. You guys could use that because you made sure your attempts pegs were all unique. And that's hashable. Pegs is an array of string in your solution. Arrays of strings are hashable. Arrays of hashable things are hashable, so everything's hashable. And it doesn't change either because you don't allow the attempts pegs to be changed. Once you hit guess, that pegs are frozen. So you see how that would be a great other way to do this? Yeah, and that's exactly what I said here. Now, what if you have no such var handy, though? Okay, if you don't have something like pegs, which are a unique, hashable, stable identifier for the things in your attempts array or whatever, then you have to go to some other solutions, okay? And option 2 here is to implement this identifiable protocol on yourself and calculate some sort of unique, stable, hashable identifier for yourself. Now, let's take a look at this weird-looking protocol right here. The first thing we want to understand is that really it's just var ID. You see the var ID part right there? That's what this protocol is. It has one thing in it, var ID. That's what you have to implement to be identifiable. Now, let's look at the rest of this kind of wacky thing. You see the associated type ID right there? That's a way to specify a don't care for a protocol. We know how to do don't cares for concrete types like array, right? We said struct array angle bracket element. That made element be the don't care for array. This is how we can do it for a protocol. Protocol identifiable associated type, this is a key word, ID, makes ID be a don't care for identifiable. And why is the ID a don't care? It's because your ID can be any type you want as long as it's hashable. Okay? You see? It says associated type ID : hashable. Right? So the ID has to be a hashable thing, which makes sense. Again, if you're identifiable, whatever they're using to identify you, you're probably going to use it in a hash table to go look things up. And that is just constraining a don't care. It looks different from where element : something, but it's essentially the same as a where clause right there. Now, the self ID is kind of weird. You see it says var ID : self.id. Why doesn't it just say ID right there? Well, if you think about this type that you're going to use as your identifying type, which can be any hashable thing, other people want to be able to find out what that type is. And they can find out by using your type name .id, capital I, capital D. So if we made code implement identifiable, then code.id, you see that down there in green at the bottom, would be the type of its ID. It just makes an easy way to specify it, right? And you can also think about what's going on here, right? You have a protocol, you're implementing that protocol, it's got a don't care. That don't care is specific to you. That don't care is the don't care for code, not the don't care for the ID for something else. See what I mean? All right. So if we have identifiable things and we want to use for each, what's really cool about for each is that the ID argument defaults to \.id. And of course, \.id means the ID var in the thing, which is what identifiable makes you put on there. So a lot of people like to do identifiable on things in a for each just so they get beautiful code like this. You see this beautiful code in green? For each attempts, no ID : \, no dot indices, none of that stuff. Just for each, and maybe it would be for each game dot attempts in this case, It looks nice. I agree, it does. And if you make the attempts, which are codes in our code breaker, if you make them implement identifiable, you can do this code. And it does look really beautiful. And I'm not opposed to that strategy. Okay? I think it looks okay as long as the identity of a code always means the same thing in all contexts, then I think this is great. You'll also see people sometimes say var ID is of type myself's type, and it's implemented by returning myself. Okay, that is a way to do ID : /self, but not have to put ID /self. You see what this is doing? So var ID : self, I'm implementing the identifiable protocol here. The type of my ID is myself. I better be hashable, by the way. And I'm implementing it by making a computed var that returns myself. Everybody cool with that line of code? Yeah? Yeah, so the question is, what is the difference between \.id, you see it at the top of the screen right there, and \.self, which we've been using with indices. Well, \.self means the var self, called self, lowercase self, which is myself. That's my entire struct. And ID means the var ID on myself, a different var. See? So self is just a special var. Every struct has a var called self, which is itself. Just returns itself. Sorry, what if?
Reference to one of the specific type parameter? Or?
The \.self?
Yes.
It's not referring to a type, it's referring to a var. \.self that we've been using all quarter in the for each, that's talking about the var self on the things in the collection, which we were using. They were indices. We were using that as its identity. All right. So what if I don't have a var that I can use and it's hard to figure out what one would be, but I want to implement identifiable. Okay, I need identifiable. How can I go figure it out? Well, there's two ways to usually implement identifiable. One is to try and calculate one based on your vars. Okay, go through your vars. Is there some way to look at all your vars and calculate an identifiable thing that it uniquely identifies you and is hashable and is stable? Right, so that's the number one way that you want to do it, and it's number one, and you always want to try it first, because there is number two, which you only want to try as a last resort, which is to use an external identifiable thing, like UUID is an example of this. Okay, UUID is a struct that creates a global unique identifier. You could create one of those and have that be your ID. So you would have var ID : of type UUID equals a UUID that you create. You see what I'm saying? Again, don't go there first. Go there after you've exhausted the possibility of calculating one based on your own vars. All right? Yeah, always refer the former to the latter. Now, interestingly, Swift can automatically synthesize the identifiable protocol for classes, not structs, for classes. And you can understand why this is. I mentioned earlier in the quarter that classes have a real good sense of their identity. It's the pointer to them. Okay, that's extremely unique, also hashable, right? And also stable. So that's great. So if you tell a class to be identifiable, it's just going to easily be able to synthesize an ID that does that, right? And let's talk about classes, right? I told you that this discussion we were going to talk about classes, so here we go. What is a class? It's an object-oriented class, just like from other languages. It has funcs and vars and everything like that. It has single inheritance in Swift, which we don't even use in SwiftUI. SwiftUI does not use the inheritance capabilities of a class. The only thing SwiftUI uses about a class is its reference semantics. That's what we use from a class. And that is the huge difference between a struct and a class. The classes are reference types. That means that when you're passing a class around to various functions, you are passing a pointer to it. And that means that the function that you passed it to can do anything it wants to that thing. Damage it to its heart's content. You didn't pass it read-only. It's dangerous, but it's also really powerful and flexible. And it's really great when you want to completely read, write, share something with another function, right, or another view or whatever. It's really great for that, but it comes with some responsibilities because you're giving it to someone, they could mess it up. So it's kind of a double-edged sword of wonder and not so wonderful things. So the bottom line is we're going to mix. We're going to use classes kind of at the top level of our model, like CodeBreaker will be a class. But we're still going to have code and kind and match and all those things be value types. And we're still going to use @sign binding down there, but we will not have to use @sign binding for the top level CodeBreaker anymore because we're going to pass it around by reference. So we don't need @sign binding, right? We're passing a pointer to it. The view can do anything it wants to it. All right? So it's going to be a combo, a little bit of a combo feel here. But there's some problem with classes, which is all that mutating func and all that stuff that lets Swift know when a struct is mutating something doesn't work for classes. You can change classes. Swift has no idea you changed that thing, right? It doesn't keep track of when you're dereferencing the pointer and going and changing things over there. So that is a problem. Because we have a reactive UI system, and that reactive UI needs to react to changes. And if I can't tell that the class is changing, I'm totally out of luck. So we are going to put this macro @observable on all of our classes in our model. So we will be putting this on our class CodeBreaker. We'll be changing CodeBreaker from being a struct to being a class. And we're going to say @observable class CodeBreaker. Now, what does this @observable thing do? I think it's best seen by example, and so I'm going to do it to show you what it's like. But essentially what @observable will do is taking all your vars in your class, I mean all of them, and it is kind of doing the same thing as @binding is doing, where it's creating a little hidden var, like an underbar one, and then it makes a computed var, and the computed var is the one you're actually interacting with, and it's changing the underbar one, which is in the heap, but it's also letting SwiftUI know it got changed. It's doing a whole bunch of stuff. It's really a ton of code that it's generating, but you really don't care about it. It's just like @sign binding. You really don't care that that's going on. To you, what it seems like is every time you change one of your vars in your class, the UI updates. It's a miracle, okay? And that's obviously what we want. And so it works really great. This @observable is a really fantastic macro. It's amazing what it does, and we are going to see that in action when we get to it. Now, I had room here to actually do a little demo about Equatable, Hashable, and Identifiable, but I kept you a couple extra minutes last time, so I'm going to let you out a couple minutes early this time. So I will start off on Wednesday by doing that, and then we're going to start into the main demo for this week, which is going to be taking our CodeBreaker and make it a much more powerful app, have a lot more in its UI. For example, we are going to have our main view when we boot up our app is not going to be a CodeBreaker game, it's going to be a list of CodeBreaker games. Okay, a mastermind kind, the earth tones kind, different color schemes and all that stuff that we can pick. And you can imagine for your A3 that thing, imagine when you booted your app up, which is what you're going to do for A4, it showed you a list of all the games you've played. All right, and maybe how long it took to play each one or whatever, and you can create new games there. You can delete old games. We're going to learn all about how to do all of that stuff. And that's going to take me both Wednesday and next Monday. So your A4, I'm going to actually ship it out on Wednesday so you can take a look at it. And a lot of what I do Wednesday, you'll be able to apply to your A3 to get it going. But you'll still need some stuff from Monday, so it's not going to be due until the Monday after that. Right? So A4 will not be due next Wednesday. Even though it's going out this Wednesday, it'll be due the Monday after that. Because I want to give you a full week after what you see on Monday to incorporate it into your app, just like I did with the animation with A3.